It is working.
I don't want to be in the movie. All right. Meanwhile, my food. Okay. So last time, it's filming this way. Last time, we learned how to name binary ionic compounds. It all fits into our overarching learning goal which deals with understanding ionic compounds. We have already covered properties of atoms and ions in terms of their similarities and differences. We know how to write electron configurations for ions, how to determine which atom it's isoelectronic with. We are somewhat comfortable naming ionic compounds that are binary. You're going to learn how to write chemical formulas today, which is easier than what you did the other day. And we'll get into the polyatomic ion containing compounds as well. The one piece I wanted to finish up with from last time, when we were naming the compounds, and this is going to lead into what we're going to do today, is it says in B that the chemical formulas for the ionic compounds indicate simplest whole number ratios of ions. So for example, with sodium chloride, this is a 1-to-1 ratio of sodium ion, the cation, which always goes first, to chloride ion, the anion, which goes second. In calcium fluoride, it's a 1-to-2 ratio of the cation calcium and the anion fluoride. So you'll always find 2 fluoride ions to 1 calcium ion, and we'll elaborate on that in a few minutes. I also want to review some of the basics with you in regard to charge that we talked about previously. We're going to look at the steps in writing the chemical formulas first for binary ionic compounds. We'll mention the steps first. You may not fully get the steps until we actually implement them, so give it a chance. Step 1 says, write the chemical symbol and charges for the cation and anion side by side. So cation, positive, then anion. And we know how to determine their charges already. We know that groups 1 and 2 have 1 plus and 2 plus charges respectively. We know aluminum in most of group 13 is 3 plus. We labeled off your periodic tables last time. Vinny, do you have yours? Your periodic table? Here, give it to me. We'll label it up to review and we'll catch you up.
It's mostly labeled.
Oh, you did it already?
Yeah.
Okay. Nope, it'll be perfect. We'll review right off of it. Good. All right. So on the screen is Vinny's periodic table, and we'll make sure it's perfect. So for example, group 1, 1 valence electron, which it will lose, forming a 1 plus charge. Group 2, 2 valence electrons, which they will lose, forming ions with 2 plus. Group 3 will be 3 plus. We're not going to play with group 3, so we don't really care about it. Your transition metals, for the most part, are variable. So what do you need after the name of a transition element?
The Roman numeral.
The Roman numeral, which indicates what?
Electron. Charge.
Charge. Charge on it. Very good. The only elements other than group 3 that don't need a Roman numeral are zinc, cadmium, and silver, because zinc and cadmium are always 2 plus and silver is always 1 plus. Aluminum and most of group 13 is 3 plus only, not 3 minus. Group 14 is 4 plus or minus. There is some variation in groups 13 and 14. And be careful with 2 elements in group 14 because they form ions of 2 types only. Tin is what? 2 plus or 4 plus, and lead is the same. Good. All right. Group 15, 3 minus. Group 16, 2 minus. Group 17, 1 minus. And group 18 has no charge. All right, so you've got the charges on the ions. You've got the ones that don't need Roman numerals. We'll hit that again. Tin and lead will, because they can form ions of multiple charges. And that's all the rules that are listed there, which we already covered the other day. So we've listed the cation with its charge and then the anion with its charge side by side. In step 2, it says crisscross superscripted charges. When you're super, you're above. So a superscript is up high. You're going to crisscross those and make them the other guy's subscript. If you can reduce those crisscrossed pieces, you will. So if you had a 2 and a 2, you'd make it a 1 and a 1. If you had a 2 and a 6, you'd make it a 1 and a 3. If you had a 3 and a 6, you would make it a 1 and 2. So just baby math. And then you get rid of the plus or minus. And I'll show you how to implement each of those steps right here. So we're going to write the chemical formula for the following binary ionic compounds. And these you can write right into your packet. For example, the first one says sodium chloride. Oops, started to do it. And chemists use a whole different language than these long names to represent compounds. They use chemical formulas. The way you do it is by following those 4 steps listed. So sodium is Na. Sodium is in group 1. What charge would a sodium ion have? 1 plus. Chloride. Chlorine's in group 17. What charge would chloride have? Not 7. 7 valence electrons. You gain 1 to have a 1 minus charge. So we wrote the cation and the anion side by side. The 1 goes here. The 1 goes here. You can't reduce 1 and 1. Plus and minus go away, and you have sodium chloride.
Does it matter about where you put the positive and negative charge signs?
Here?
Yeah.
Absolutely. The first one's always positive, second one's always negative.
When they cross, they don't change the signs.
When you crisscross, the charge goes away. What this is saying is you have 1 sodium ion and 1 chloride ion.
Oh, because they neutralize.
Right, for electroneutrality, exactly.
Can you always, like, do they always crisscross or no?
Always.
Okay.
We're going to do several. Calcium oxide, calcium, group 2 has what charge? 2 plus. Charge is a number followed by plus or minus. Oxide is 2 minus from group 16. This 2 would go here. This 2 would go here. However, after you crisscross, you must reduce if you can. 2 goes into both of these 1, and your chemical formula is that way because the subscripts are the simplest whole number ratio of ions. For every 1 calcium ion, there's 1 oxide ion. So you have 1 calcium ion and 1 oxide ion, a 1-to-1 ratio.
So for elements or compounds in electron neutrality, it'll always pretty much just be like a 1-to-1 because the charges will balance.
If you have group 1 and 17, yes. If you have group 2 and 16, yes. But now let's look at the next example and you answer the question. So for example, if you had magnesium fluoride, magnesium's in group 2, what would its charge be?
2 plus.
And fluoride?
1
1 minus because it's in group 17. The 2 goes here. The 1 goes here. So this is not a 1-to-1 ratio, correct?
Yes.
All right, so I'm not sure if that was your question. Yeah, so be careful. So you have 1 magnesium ion, and to neutralize that 2 plus charge, you need 2 fluoride ions. And typically, if you have 1 of something, it goes in the middle, and the other pieces go outside. Aluminum sulfide.
So the both still always neutralize it.
Yeah, electroneutrality, what you're going to see here is you'll always have 1 2 plus for 2 plus, and you're going to have 2 of the 1 minus for a total of 2 minus, and when you add them together you get 0, because that's electroneutrality. That's a great question.
So since aluminum is variable and since it's the ion,
Aluminum is not variable. Aluminum is in group 13, but it's always 3 plus, which is why it doesn't need a Roman numeral.
Why did you split up the fluoride in magnesium fluoride?
If you're writing the chemical formula, it's this. If you're asked to draw it, which I won't ask you to do, it's this. For every one of these, you have 2 of these. And the reason why I split them, if you will, is you don't want 2 negatively charged ions so close to one another because they repel. So
But
you're
that's
going
not
to,
be on the quiz.
no, you're going to be given this and asked to do this.
Okay.
So it'll say write the chemical formula for the ionic compound.
Okay.
Okay. The next one is aluminum sulfide. Who wants to help? Fire away, kid.
So aluminum is 3 plus,
Absolutely.
and then sulfide is 2 minus,
Good job.
and so then they cross over, and it's Al with a little 2 and S a little 3.
You got it. Easy peasy, right?
Yeah.
On the test, like for calcium oxide, you would just put calcium and all, like you wouldn't need the 2 plus 2 minus.
No. Whereas the Roman numerals in our previous lesson were tricky wicky, they actually are super easy in this section. So your next example says chromium 3 phosphide. The 3 represents the charge on which ion? You got it. So this is chromium 3 plus. Phosphide would have what charge? Sebastian, why is it 3 minus? It's 3 away from 18, or it's group 15 with 5 valence electrons. It gains 3. Whichever way you want to think of it is good. They cancel out, so you don't even have to write the 3's. Whenever you have 2 ions with opposite charges that are the same, you have 1 of each at the end. 1 chromium 3 ion to 1 phosphide ion.
Chris.
We have manganese. Seven is correct. Bromide. Who wants to do it with me? Go ahead.
Okay. So since the 7 goes with, that's 7, right?
Mm-hmm.
It goes with manganese.
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 Okay.
And since it's bromide, where is it? I just lost it for a second.
Look to the right, to the right, to the right.
Yeah. Alright, and it's 1 away, so it's gonna be 1 minus.
What did you say? It's what? I know you said it's 1 minus, but what did you say before that?
It's 1 away.
1 away, okay.
Yeah.
Now what?
Oh, you cross them.
And what do you get?
MN1
Okay,
by itself, I guess. And then BR7.
you got it. I would like you, without yakety yakking, try the 4 on the screen. I'm going to put the 4 on the screen in case you don't have your notes, and I will get those answers for you. Say it again.
BI.
Is 6. And I'll do them here.
Wait, why does it say manganese 6 the next one?
Manganese has the ability to form ions with multiple charge. It's a D block element. That's why it needs a Roman numeral. Actually, it can be 2 plus. Manganese is interesting. It can be 2 plus, 3 plus, 4 plus, 6 plus, or 7 plus. Quite a bit.
So that's what the Roman numerals indicate about these ions.
So if it's like a transitional metal or like in group 13 or 14, it'll always give us the Roman numeral.
No. No. Most transition elements do get Roman numerals, but not group 3, which we won't deal with, not zinc, cadmium, and silver, the J, and be careful, only from group 14 for sure do you need Roman numerals for tin and aluminum's always 3 plus, no Roman numeral. Tin and
Lead.
lead. Those are either 2 plus or 4 plus, so they do need Roman numerals.
Can we use our own periodic table?
You can. On your quiz, no.
Wait, then for like carbon, what would we put?
Carbon's one of those weird ones, and if it's a carbide in the back, it's going to be 4 minus. Good morning or good afternoon. Thank you. Oh, Max, you're going home. No, it's fine. Max, we're filming, so you'll be able to get it all. All right, finish those 5. Come on. Don't lose your drive here. Hey!
She's been bullying me the entire time.
Come on, guys, you got this.
I know like which one coordinates to which, but what's the difference between a subscript and a superscript?
Superscript is high.
I know like that's what I'm saying. Like I know where it is. I just like why. What's
The
difference?
superscript is telling you the charge of the ion, and the subscript is telling you how much of the ion you have.
Okay. So like how many?
Yep.
Okay. Ah, we're so far. Oh, I found it.
Yeah, it's on scary.
I did it.
I think there's one on the next page of your notes. You sort of got cut off. Make sure you do them all. Let's go. Let's go. One more next page.
Max, say hi to Sam.
Oh, okay.
Say hi to Sam.
We will announce it at the end. Watch the video. I think we will.
Did you do the, all of these? I did.
Yeah, but watch
What
the
did you
video.
do for the nickel? Like, what was the charge of the nickel? 92?
What's the 15?
That's
Well, I highlighted 4, but they're actually, we didn't do this one, so you should be doing these 5, right? Most of you did. Yes, darling.
If it's a Roman numeral, how do you know if it's positive or negative?
Always, Exactly. Good, good, good. First one's always positive. See? There was tremendous focus yesterday. I could feel it. It was good.
So was I, just for God.
If it's just
One more minute.
if it's just a single one, it's
I'll
one plus.
I'll put the slides, I'll put the step this class, I'll put on like,
Yeah.
all the rules we're going on one line.
All right. Let's see how we did.
The last one, did you get C or S?
Ta-da! Did we get it? Did we get it?
I did finish.
Why don't you say magnesium trisulfide?
It's first of all, it's manganese.
Oh, I mean,
And we don't typically use, let me rephrase, we don't use prefaces with ionic compounds, even though you will see it on some food products. But with ionic naming, unless you've got a polyatomic in there, and I'll explain that in a few minutes, you don't use prefaces. All right, so I hope you feel pretty comfortable with naming and formula writing binary ionic compounds. The binary ionic compounds end in I, D, E. And we are going to take the basics that we know how to do now, and we are going to name and write chemical formulas for ionic compounds that contain more than 2 atoms. Not difficult, probably easier than anything you've seen. Okay? I also just want to show you just how much chemistry can affect you each and every day, and you'll see this in a project that you are going to be doing this quarter, and I'll announce it more toward the end of the week, beginning of next week. What you're going to see is that ionic compounds, let's refocus, guys. Ionic compounds are in many household materials, food products, etc. And we can look at some of your food products that you probably still have in your bag unless you've finished. There are 4 ionic compounds in Arm & Hammer powder laundry detergent. Of the 4 listed, raise your hand and tell me which one is the binary ionic compound. Rebecca.
Potassium chloride.
Potassium chloride. And how did you know that?
Because it ends in ide.
It ends in ide. Now you'll have to be a little careful with the ide concept, because generally speaking that is true, and it is true here. But another way you know it's binary is it contains 2 elements. So you have potassium chloride. This is the binary ionic compound. The other components listed there, sodium carbonate, sodium sulfate, and sodium bicarbonate, are all ionic as well. An ionic compound has a metallic cation and a non-metallic anion. But what you see in those 3 examples, here you have 1, 2, 3, 4 atoms, 1, 2, 3 atoms, 1, 2, 3 atoms. And you have different atoms, if you will. So those are ionic compounds that contain polyatomic ions, and we're going to learn how to name and formula write these as well. It's very, very easy. It follows the same rules that we talked about yesterday and today, and you'll be very, very successful with it. A polyatomic ion, what does poly mean? Many. A polyatomic ion is a charged group, because it's an ion, of two or more covalently bonded atoms that function as an ion. For example, and this is where I said you do need to be careful with the IDE ending, because there are 4 polyatomic ions that end in IDE, and for another reason we'll address later. Hydroxide ion, it's a polyatomic ion. You have the following, where O is covalently bonded to H. I'll teach you how to draw these later this 9 weeks. Don't worry about the drawing right now. Negative charge. So in a polyatomic ion such as hydroxide ion, you have 2 or more atoms that are covalently bonded, and there's a charge over the whole piece. Similarly, sulfate ion, this one's a little bit crazy. I told you didn't have to draw it. Don't freak out on me. It's not a carbohydrate.
Boy. I think I'm just gonna stop drawing.
Yeah, you don't need to draw it. Just look.
Well, we're going to, let's do that.
Not quite this complicated. All right. So a sulfate ion, again, it's polyatomic. It contains more than one atom, and they're covalently bonded, and it has a charge on it. These are polyatomic ions. More than one atom, covalently bonded with a charge. Now here's the super good news. You do not need to memorize the polyatomic ions this year. They are on the back of your periodic table, making life much simpler. Yes. Ask me one.
No.
Okay. Hypochlorite. ClO 1 minus.
How about
All right.
methyl
Methyl ammonium. CH3 NH. I'll get it. I can draw it. NH3 plus.
Methylammonium.
That's the one you just asked me. All right. Monohydrogen phosphate. HPO4 2 minus. All right. Shh. Guys, that's not up there. All right. Shh, shh, shh. Your polyatomic ions are here. Acetate ion, ammonium ion. Which of those two is a cation, ammonium ion or acetate ion? Ammonium, because it has a positive charge. Arsenate ion, azide ion. Note azide ion has 3 of the same atoms bonded together covalently with a 1 minus charge. Also note that azide ends in IDE. What other polyatomics end in IDE?
Hydroxide.
Cyanide, hydroxide, and peroxide. So there are 4 that end in IDE. Be careful. Cyanide and azide are used to kill people, just for the heck of it. IDE. Hydrogen peroxide is not used to kill people. That's used to clean out wounds. And also, I don't know if you're aware of this, but hydrogen peroxide removes blood from anything. So if you got into a fight with somebody and you got blood on your shirt, hydrogen peroxide, it removes it like magic. It disinfects as well. You don't want to eat it? That's yucky.
What if you put it on
Nothing's going to happen. All right. Let's refocus. Are these provided to you? Yes. Do you have to memorize them? No. Now, I'm going to show you the tricks to learn them.
No.
But this year I'm going to show you the tricks after I teach you how to name and formula right with them.
Why does it say you have to memorize this?
For those of you who go on to take college chemistry at college or AP chemistry, you would need to know these. And it's really not hard. So Alex, for example, since you asked, and I'll go over this in more detail in a little bit. Come on, guys, you can do this. When you look at sulfite and sulfate, do they have the same charge? Really? Yes, they do. Their charge is both 2 minus. They both have S, they both have O. What's different about sulfite and sulfate?
Spelling.
Not ion, but sulfite has one less.
No one.
The grade you never want to get in on a paper.
Zero.
An A, yeah, that's what you never want to get. That's just silly. Sulfite has one less O than sulfate. Look at nitrite and nitrate.
Oh, they have O.
See, nitrate has one less O than 8. Look at iodite and iodate. Ite has one less O than 8. So there are tricks in learning it.
Why is it changing colors?
Oh no. All right. So I will go through. Let's refocus, please. I will go through the polyatomic ions in terms of memorizing them for those who want toward the end of class, because I want to make sure you have a lot of practice in class with naming and writing, because that's what you're going to see on your quiz. So I'm going to skip down to E, naming compounds that contain one or more polyatomic ions. So now what you're going to see is you're not going to have binary anymore. You're not only going to be working off the front part of the periodic table. This looks hard. It's easier than anything we've done because you already have the background. The first thing we want to do is name. For the naming, very easy. Nothing to memorize. Ca, again, it's the name of the element for the cation. If the anion is polyatomic, you just flip to the back of your periodic table and you find it. So you've got a monatomic cation, so it's calcium. OH, what did OH represent on the back of the periodic table? Hydroxide, calcium hydroxide. If you have a monatomic cation, it's the name of the element. Mg is magnesium. Now look at CO3. That's more than one atom. You're looking on the back. CO3 is carbonate. Magnesium carbonate. Al is a monatomic cation. Al is aluminum. PO3 is phosphite. Okay? Phosphite. Aluminum phosphite. Why didn't I give aluminum a Roman numeral? Because it doesn't need one, because it only forms ions with a 3+ charge. Now, this is tricky because we're getting back to these crazy Roman numerals. So let's look at this one slowly. This is a little trickier here. All right. Here we go. When we tackled this with the binary, we looked at the charge on the anion. SO4 is? SO4 is sulfate. And the charge is? 2 minus. Look up. Look up. Look up. 3 times 2 is 6. Divided by 2 is? And this becomes iron 3 sulfate. We'll do several of these, don't panic. Monatomic cation, that takes the name, that's vanadium. Vanadium is a transition element that has the ability to form more than one charge. What is C2O4? Look under O. Oxalate. And what is its charge? 3 times 2 is? 6. Divided by 2 is?
3.
So it's vanadium 3. Go ahead, Rebecca.
Isn't it always just going to be the one with the cross, though?
Not always. Because if they cancel, it
Oh,
won't. Be careful. Sometimes, yes, you can lift them. Other times, no. Because if you had vanadium 2 oxalate, you would have had this. And what would you have guessed?
Okay.
That would have been a mess. So be careful. Good question, though. All right. Now, this one's a little bit different. There aren't that many polyatomic cations, but you can see right away that they're grouped together. So NH4 is ammonium. And this is where you also need to be careful, where I do see kids making errors. You've got a monatomic anion. So it would be sulfide. Okay? Let's do one more together and I'll let you try. Na is? Does that need a Roman numeral?
No.
You better not. SO3? Sulfite is correct. There are 3 more in your note packet. Well, there's actually a whole bunch, but you'll start with the 3. And I want to set aside as much time as possible, which is looking like we're going to have a lot for practice. So try those 3. I'll name them on my paper and I'll come check you. Be very careful with the last one. I think that may be a little tricky. Be very careful here. Spelling counts. You've got these things written on your periodic table. And naming and formula writing require quite a bit of practice. So we're going to give you some in here and you'll need some at home. Who's done? All right, if you're not done, don't look at the screen. But if you are done, here are the answers. I'm thinking the last one may have been a little challenging for you.
I thought it was.
We'll do it.
I got it right.
Great.
Wait,
Because look, you do 2.
No, 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 no.
No.
No. You got lucky. Take a look. Take a look.
yeah, you,
When you're trying to figure out the charge and you have a polyatomic, put the polyatomic in parentheses. What's the charge on nitrite?
2.
What's the charge on nitrite ion?
minus
1.
minus 1.
The 2's inside, you don't count that. 1 times 1 makes copper. 1 plus. We can do another one of those.
Wait,
Very tricky.
wait, I just have a question about it.
Hang on one sec. In regard to the copper, put the polyatomic ion in parentheses. There's nothing outside of the parentheses. The reason why you don't have parentheses is because you have one of them, and you'll see that in more detail soon. So that means you have 1 negative, so you have 1 positive. Similarly, if you had this, what's the polyatomic? What are we putting in parentheses? Sulfate. So what's the charge on the sulfate? 2 minus. So what's the charge on the copper? 2 plus. So this is copper 2 sulfate. That can be tricky. It requires practice. So if you were to look on these, I don't want to go through all of these right now. I'm going to let you work on these in small groups, but there's one more little section I want to do. But let's make sure we've driven this point home. Highlighted in yellow, take a minute to do this one.
Why for mercury on this thing on the back of the periodic table does it have a Roman numeral 1 if the charge is 2 plus?
Mercury is very, very tricky. If you had Hg only with 2 plus, that's mercury 2 ion. But if you have Hg with a subscript of 2, you have 2 of them with 2 plus total charge, so each one is 1 plus. Very tricky. I won't give it to you this year. So try and do that one I highlighted in yellow. Let's see if you've got it. It's very tricky. Be careful. What'd you get? Nickel. Nickel 1. Careful, careful. Look, look, look. Ready? Put it in parentheses.
That's what I did.
1 times 2 divided by 2 is 1 plus.
Oh.
Oh.
Wait, so it's the same as the binary ones, but kind of different?
The only thing trickier or different about it is put the polyatomic in parentheses. You know you have one of them. And that concept that you have one of them will be clear in the next section. All right. Yep.
What about when, like, for the one we did where it was like Al2CrO4 and then parentheses 3 outside? There's 3 of the polyatomic one.
So you had Al2CrO4 with a 3.
Yeah.
This one's a lot more straightforward because you have the parentheses, you know you have 3 of them.
Oh.
Your approach there, and plus the fact you know what the charge on aluminum is, you don't need a Roman
Well, like,
numeral.
if it was one where you needed a Roman
Okay, so for example, let's do,
Yeah, that one confused me.
we'll do 2 of these, watch. So let's look at these 2 examples. How do we approach this one?
Whoa. Oh.
You're going to do what right away? Put the parentheses in. What's the charge on a chromate ion?
2 minus.
So you have 1 of that. The charge on iron has to be what?
2 plus.
2 plus. So that's iron 2 chromate. Now look at this one. This is 2 minus. 3 times 2 is? Divided by 2 is? So this is iron 3 chromate. Go ahead, Rebecca.
Okay, so you multiply the 2 minus times the 3 and then divide it by the other 2?
Yep.
And you do that every time?
Yep.
So you multiply and then divide?
But if you don't have parentheses, put them in because you don't want to multiply the 4 times the 2. If you don't have parentheses, you automatically have 1 of it.
So that one would be 2 divided by 1, so 2 plus. Okay, got it.
All right. We know how to go from a compound that contains a polyatomic ion to the name, and now we want to go backward. We want to go to the name, from the name to the chemical formula when you have a polyatomic ion. Same steps you followed previously with one trick. Again, you're going to write the cation and anion side by side, but if you have a polyatomic ion, put it in parentheses with the charge on the outside top right corner. If you have a polyatomic ion, put it in parentheses with its superscripted charge outside the parentheses. That's the key to doing this. Then you do the exact same thing. You swap and drop and you reduce. Oops. You only, girls, reduce numbers that you've swapped and dropped. You never, ever, 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 ever reduce a subscript that was initially part of the polyatomic ion. Put the polyatomics in parentheses. Put the charge outside the parentheses. Swap and drop. Reduce only swapped and dropped numbers. Let's walk through a whole bunch of this, and then we're going to do a whole lot of practice. All right. The first one is sodium hydroxide. Here's my approach. Sodium is a monatomic cation. It's in group 1, 1 plus charge. Nothing different there. We learned that on Monday. Hydroxide is a polyatomic. I put it in parentheses with its charge on the outside. The one goes here, the one goes here. Initially, I have this. Only if the number outside the parentheses is 1 can you drop the parentheses. So if the number outside the parentheses is 1, you can drop them. Only if it's 1. The next one says barium chlorate. Barium's in group 2. What would its charge be? 2 plus. Chlorate, is it polyatomic? It ends in 8. What's chlorate? ClO3, we put it in parentheses and its charge is 1 minus. The 2 goes here. The 1 goes here. Okay. Not hard.
I get it.
But you need the parentheses. Now, why didn't I drop the parentheses here? I did it here. Because it's not a 1 outside, and don't you dare drop them. You will make a mess. The next one says aluminum. Nitrite. Dean, how do we do this one?
You put the AL in the
Aluminum's on the front, honey.
I know.
What's its charge?
Minus
It's in group 13.
minus 4, 5, 3. I don't know.
Why is it 3 plus?
So there's electrons.
Go ahead, Isabel. Why is it 3 plus? Huh? Aluminum always has a 3 plus charge. She is correct. It's in group 13 with 3 valence electrons, which it will lose. Nitrite is what, Dean?
NO3.
Nitrite.
Oh, my bad. NO2.
Should I put it in parentheses?
Yeah.
Yeah. And what's its charge?
Minus 1.
The 3 goes here. The 1 goes here. Yes? Let's try another one. Iron. 3. Oxalate. We know we have Fe. What's the charge on iron?
3.
Oxalate. C2O4. Should I put it in parentheses?
Yes.
Charge. 3 goes here. 2 goes here. And we have Fe2. C2O4 3. Sorry. One more. Chromium. 6. Phosphite. What do we do? do we do? Go ahead, Alex. That's a 6. Oh, you want to do the answer already? Can you walk me through first? Plus or minus? PO3, 3 minus? Okay. Hang on. So you had CR3, PO3 with a 6, and then what? That's exactly right. Excellent. How come you did not touch that 3? Because it was in the parentheses. It's part of the original polyatomic. You only reduced, swapped, and dropped. Okay? There are several things we still need to do today. I know you want a break. We need to finish all of these. We're going to go back. I'm sorry. We need to finish all of these. We're going to go back and work these up as well to make sure we've got it. I have listed here, but I don't think it was in your notes, a website that has some practice. I can ship that out to the to remind. But this is kind of cool. You can pick the names right away, and you can see if you're right. It's probably good practice for you. I'd recommend it. For those of you who just like to play with electronics, there's a cute iPad app that I will show you. I got the whole packet. I think it was $1.99, but the piece I'm looking for you, I believe, is free. So if you want to try that, I'll show you that as well in a few minutes. And I'm asking you also, you can do classwork 2-1. You did some of it last night. You can do almost all of it, but you cannot do the last 2 questions, 25 and 26. We haven't gone over. 29 and 30. We haven't gone over. Everything else is doable after a short break. But the take-homes today, can you write chemical formulas for binary ionic compounds? Can you name and write chemical formulas for those that contain polyatomics? I don't think you're ready for a quiz on Thursday. Your quiz will be Monday. I will tell you how much it covers on Thursday when we get into oxidation numbers, and we'll see how we do. Yes, you may. So we